Hi, my name is Alexander and welcome to yet another unboxing and first impressions video of the nanoLuka channel. What we are going to open up today is a brand new power supply by Velleman. It provides DC voltages up to 30 volts and currents up to 3 amps. Without any further ado, let's open it up and see what's inside. Now that I've hooked up the device, let's take a closer look and see it in action. To do that, we're going to use our friend from one of the previous videos, the multimeter we've unboxed just a couple of weeks back. So let's see first what do we have here. Again, this power supply is by Velleman. It's LABPS3003. We have two LCD displays. Each is going to show the value of current and voltage, and then we have here fine and coarse tuning for each. Finally, at the bottom we have the power supply button and the outputs right here. The black and the red one are going to give us the voltage and the current, of course, that we set up here, and then the green one is actually the grounding of the box, of the housing. Okay, let's start by firing it up. Okay, the first thing we note here is that it's all zeros. It makes sense because it's all just zeros. It's all the way to the left, and then we see this one, the black one, this red lamp on. So what this means is that the current protection is activated. Basically, no current is allowed through the outputs. That further means that no matter what we do with the voltage here, how high we set it, nothing will happen up here because the current is currently completely blocked. So no purpose in setting up the voltage either. To avoid that and make it actually appear as a real power source, let's turn off the current protection by allowing some current out, and we see that now you can set the voltage anyway we want, between 0 and it says 30. Let's see how high. Okay, 29.4. Let's make sure that it's telling the truth. So let's set it for voltage and then appropriate range. Okay, I'm going to put these to make it easier to access the outputs. See if I can make the contact. Okay, we have 29 point something volts. Okay, let's say that that's close enough to 30. Okay, let's now see what's the greatest current we can provide with using this power supply. It should be about 3 amps, but let's make sure it's telling the truth. The way to do that is to short circuit the outputs. Yeah, it probably sounds a bit crazy, but that's actually how the device, how the power supply is made, was designed to work, to operate. What we are having right now is the multimeter in the voltmeter configuration. So it is basically drawing no current, since in the voltmeter configuration the multimeter behaves as if it was an infinite resistance. Hence, we measure the voltage. If we want to measure the current, we need to switch the multimeter into the amp meter configuration, the current meter measurement configuration, and once we do that, the multimeter is going to present itself to the source, to the supply, as if it was a zero resistance, a short circuit, so-called. It sounds a bit dangerous, but it actually is not. As I've said, that's how the power supply is supposed to work. So what is going to happen, it is going to activate its current protection once we short circuit it. Let's see it. Let's see how that happens. First, I have connected the multimeter in the appropriate socket here. So we can receive up to 10 amps, since I don't know where the which value is right here. They should put a scale here. It would make things easier. Anyway, so we have this in the amps range, and the appropriate source is right. The appropriate socket is connected. So let's see what happens. Exactly right here, you can see that the current protection activates and blocks the current. You see the sparks, and blocks the current at about 140 milliamps. Let's see what happens if we hit the maximum. Okay, so what we're seeing right now is 2.9 amps. So let's say that that's close enough to the 3 amps, and that the power supply is working as promised. So let's do an actual example at the end. Assume that we have this device under test, a DUT, that we want to power with 12 volts. And let's say that its maximum current is limited to 600 milliamps. Let's say that if this DUT of ours receives a current higher than 600 milliamps, it might be damaged. So for that reason, we are going to use the power supply to protect our device under test and limit the current to 600 milliamps. So how do we actually do that? Well, we first set the voltage to the appropriate level. I said 12, right? Okay, so that's 12. And now we need to set the current to 600 milliamps. So the way to do that is to again short circuit it. Okay, now it's now it's 3 amps. That's a bit too high, so let's reduce to oh, that's too much. Okay, somewhere there. Okay, that's 600 milliamps. We can see up here as well. So at this point, the power supply is ready to power our device under test with all the safety turned on. So basically, what's going to happen if our device under test draws or pulls current higher than the defined 600 milliamps, the power supply is going to protect it by activating its current protection and stopping any again cutting off any higher currents by and it's going to clamp the voltage to 0 once again. Let's see how that actually happens. Okay, right there. You see how the current is 600. The limit is hit at 600 milliamps, and the voltage is immediately drawn to 0, clamped to 0. In this video, we've opened up Velleman's power supply, model 3003. Maximum voltage 30 volts, maximum current 3 amps, thus maximum power being 150 watts. I'm quite happy, as I strongly believe that this will be more than enough for what we need in our lab. So thank you for watching this video. Follow us on GitHub, Twitter, Instagram. Please subscribe on YouTube in order not to miss any of our coming up videos, projects, and so on. And finally, please do consider supporting us via Patreon. Thanks for watching, and a special thank you to all the patrons. See you around.